Last May, a rocket the size of a 40-story building didn't reach the stars. It became a fireball. 3 months later, another multi-billion-dollar prototype shattered upon re-entry, scattering the dreams of engineers across the commercial flight paths of the Caribbean. And then came February, the month SpaceX quietly pulled the plug on the 2026 Mars window that had been the centerpiece of their propaganda for a decade. If you follow the news, you might see these as mere setbacks in a daring industry. But if you look deeper, you will find a far more haunting truth. Tonight, we aren't just looking at rockets. We are going somewhere stranger and infinitely more hostile than the red planet itself. We are entering the realm of the real reasons humanity is stuck. We are talking about toxic dust that shreds human lungs like invisible glass blades, cosmic radiation that deletes memories, and a landing sequence so violent that experts call it 7 minutes of pure, unadulterated terror. For 70 years, we've been told Mars is our next home. But the reality is, the dream is dying, not because we lack the heart, but because the more we understand the physics of the red planet, the worse the nightmare becomes. And the silence that follows those explosions is, perhaps, the most expensive sound in human history. Dim the lights, put your headphones in. This is a journey into the architecture of an impossible dream. Let's go back to 2004. A young, charismatic engineer stood on a stage in Washington and promised a room full of believers that humans would set foot on Mars within 15 years. The applause was deafening. The media fueled the fire with cover stories about the Martian generation, and 1 million children went to sleep imagining the smell of red dust. That engineer was Elon Musk. His deadline was 2019, but 2019 arrived in silence. No boots, no dust. Just a deadline that slid to 2022, then 2024, then 2026. Every time the calendar flipped, the speech remained the same, and every time a hopeful public bought into the illusion. Now look at the world around you. It is 2026. No human has ventured beyond low Earth orbit since 1972. Not one. The last man to ever walk on another world is gone, and the few who remember what it felt like to look back at a distant Earth are in their 90s. The future we were promised hasn't arrived. It has retreated into the dark. Here is the anomaly. Every single deadline ever set for a Mars mission has failed to hold. This isn't just a SpaceX problem. President Bush promised us the red planet by 2019. President Obama moved the goalpost to 2035. NASA's current official target is a shaky date in the 2040s that no one actually believes in. China dreams of 2038, and Russia has abandoned the chase entirely. Even the European Space Agency stopped pretending decades ago. You might think it's about a lack of cash or political bickering, but the truth is far darker. It's something most documentaries are afraid to say out loud. The closer we look at Mars, the worse it gets. This is the era of informed despair. Every time we solve an engineering puzzle, we uncover 2 biological nightmares we didn't know existed. Every breakthrough on paper eventually shatters against a wall of chemistry and physics that simply will not break. Every gram of hope is weighed against a ton of unforgiving physics. Over the next 17,000 words, we are going to dismantle the Mars illusion piece by piece. We will explore the refueling paradox, where the sheer math of propellant fails to close. We will descend into the 7 minutes of terror, a landing sequence so complex it has a 50% mortality rate for even our most advanced robots. We will confront the chemical betrayal, revealing how the very soil of Mars is a weaponized toxin designed to shut down the human thyroid. We will look at the biological unraveling, discovering that our bones turn to liquid, our eyes flatten, and our DNA unzips like a frayed shoelace the second we lose the protection of our home planet. And finally, we will ask the most haunting question of all. Is Mars a doorway to the stars, or is it a great filter? A physical barrier designed to ensure that civilizations like ours never leave their cradle. This is the story of how our cradle became our cage. Take the Starship itself. It is a monument to human ego, the tallest and most powerful vehicle ever forged. It towers over the Statue of Liberty. It can lift 150 tons to the heavens. It is, by every objective measure, the peak of human flight. And yet, in the last year alone, 3 of them ended in spectacular destruction. This was the vessel meant to ferry us to a new life, but even the internal data now admits the math doesn't work. When SpaceX cancelled the 2026 launch, they blamed the moon. But the data shows the truth. The physics of Mars is currently a brick wall. The failure starts with a puzzle almost no one talks about. Imagine trying to drive across a continent in a car that only holds enough gas for the first 50 miles. To finish the trip, you'd have to stop and refill. But in this scenario, the gas stations are floating 200 miles up, screaming through the vacuum at 17,000 miles per hour, and they haven't even been built yet. This is the orbital refueling problem. To reach Mars, a Starship must be topped off in orbit by up to 20 other tankers, all docking with millimeter precision while moving at hypersonic speeds. We have never done it, not once. On a whiteboard, it's a simple arrow. In reality, it's like trying to thread a needle during a Category 5 hurricane while blindfolded. And if you survive the fuel, you face the atmosphere. Mars has a thin, ghostly air that is a cruel joke of nature, too thick to ignore, but too thin to be helpful. It is dense enough to turn a ship into a fireball, but not dense enough to slow a heavy craft down with parachutes. Landing a 100-ton Starship on that rusted dirt requires physics to perform a miracle it has never demonstrated. The 7 minutes of terror is a mathematical gauntlet where every step, the heat shield, the supersonic chute, the retro rockets, must fire in a perfect, lethal choreography. If the signal takes 14 minutes to reach Earth, the crew is either alive or dead long before we even know they've arrived. But the most brutal betrayal isn't in the metal, it's in the meat. Throughout this documentary, we will explore why the human body is a property of Earth. Our hearts, our bones, and our immune systems were fine-tuned over 4 billion years for one specific gravity and one specific magnetic field. When you cut that tether, the body begins to unmake itself. We will look at the twin study, which proved that spaceflight causes a biological crash that makes you age faster than your own brother. We will look at SANS, the condition where fluid shifts in the skull crush the optic nerve until the explorer goes blind. This journey is not a celebration of technology. It is a reckoning with our own limits. It is a reckoning with the very laws that govern our existence. It is about why the dream of Mars is receding into the dark, even as our rockets grow larger. We are entering an era where our ambition is finally hitting the crushing weight of the actual universe. By the end of this hour, you will see the red planet not as a new frontier, but as a warning. We are starting with the first wall, the brutal, unforgiving engineering of the void. Because if we cannot solve the fuel, if we cannot solve the landing, and if we cannot solve the poison in the dust, then the boots of our children will never touch the sand of Mars. They will stay exactly where we are, staring at a red light in the sky, wondering why the future we were promised keeps getting further away. Wait for the answer. Welcome to the real Mars problem. Let's look at why it keeps getting worse. Section 2, the Refueling Paradox, the Engineering Wall. Word allocation, 1,500 words. To understand why the dream of Mars is currently crashing into a wall of reality, you have to understand the most unforgiving law in the universe. It is a mathematical prison called the Tsiolkovsky rocket equation, but engineers simply call it the tyranny. It dictates a brutal, fundamental tax on existence. To move mass through the stars, you must carry fuel, but that fuel itself has mass, so you must carry more fuel just to move the fuel you've already packed. This creates a recursive, exponential loop that eventually hits a ceiling defined by physics. We are not building bigger rockets because we are ambitious. We are building them because we are desperately trying to outrun a mathematical curve that wants to keep us pinned to the Earth forever. This is the first and most imposing wall of our informed despair. Take the Starship. It is the tallest, most powerful vehicle ever forged by human hands, a 120-meter tower of stainless steel designed to shatter the sky. If you stood it next to the Statue of Liberty, the rocket would tower over the monument by 10 full stories. It can lift 150 tons into the heavens. It is, by every objective measure, the most advanced flying machine in history. And yet, this giant has a secret. By the time it reaches low Earth orbit, this massive structure is little more than a hollow shell. It has burned through nearly all its lifeblood just to reach the front door of the cosmos. It arrives at the edge of the vacuum with its tanks almost empty, a stranded titan with nowhere left to go. Imagine the absurdity of the situation. You have built a skyscraper that can fly, but once it reaches the starting line for Mars, it is out of gas. This brings us to a technical puzzle that no space agency in history has ever solved at the scale required for human survival. To get a single ship to the Red Planet, you cannot just launch it and hope for the best. You have to solve the orbital refueling problem. Think of it this way. Imagine you are trying to drive a car from New York to Los Angeles, but your gas tank is only large enough to get you across the first 100 miles. To finish the journey, you would have to stop and refill. But in the architecture of Mars, there are no gas stations on the road. Instead, the gas stations are other rockets, up to 20 of them, that must be launched from Earth, one after another, to meet you in the dark. These refueling ships must chase you through the orbit, matching your speed of 17,000 miles per hour with millimeter precision. They must find you in the vastness of the void and dock with you, while both of you are screaming across the sky at hypersonic speeds. It is a logistical nightmare that makes every previous achievement in spaceflight look like child's play. The choreography required for this is staggering. You aren't just docking two ships, you're attempting to mate two 40-story buildings in a vacuum. Every umbilical cord, every sensor, and every docking latch must work with perfect synchronization. And once the connection is made, the real horror begins. You have to transfer thousands of tons of cryogenic propellant from one tank to the other. But this isn't like pumping gas at a local station. You are dealing with liquid methane and liquid oxygen, substances stored at temperatures so unimaginably cold they would turn high-strength steel into something as brittle and fragile as holiday glass. In the weightlessness of orbit, liquids do not behave. They do not sit at the bottom of a tank waiting to be drained. They float in chaotic, shimmering blobs. They form bubbles that can shatter high-pressure pumps in a heartbeat. They can freeze valves shut or cause seals to disintegrate. If even one of these 1,000 moving parts fails, if one valve sticks, if one sensor misreads the flow, if one seal leaks, the mission doesn't just delay, it ends. There is no roadside assistance 40 million miles from home. You are fighting a war against the very nature of matter in an environment that wants to tear your machinery apart. And then there is the problem of the vanishing fuel. In the harsh, unfiltered sunlight of space, these cryogenic liquids do not want to stay liquid. They want to boil. They want to evaporate. Engineers call this boil-off, and it is a silent thief that steals your propellant every second you wait. This creates a desperate, high-stakes race against a clock you cannot stop. To fill a single Mars-bound starship, you need a launch cadence that humanity has never even attempted. You need rockets taking off from Earth every few days, month after month, with a 100% success rate. If one tanker rocket explodes on the launch pad, the entire schedule collapses. If two tankers fail, the 26-month orbital window, the only time the planets are aligned for the trip, closes. Your fuel quietly evaporates into the vacuum while you are forced to wait 2 more years for the next chance. You are not just fighting physics, you are fighting the calendar. The complexity is so vast that the probability of a successful refueling sequence begins to approach zero. We are trying to build a bridge to another world out of materials that disappear and mathematics that refuse to add up. In late 2024, a team of independent aerospace researchers published a sobering study in the journal Nature. They didn't just say refueling would be difficult, they suggested the current plan might be physically unworkable. When they ran the hard numbers on boil-off rates, docking precision, and launch reliability, the data revealed a dark reality. They found that the amount of fuel lost during the transfer process might actually exceed the amount being delivered by the tankers. This is the quiet reason why the 2026 mission was cancelled. It wasn't a lack of money or a shift in policy. It was the realization that the engineering wall is currently growing faster than our ability to climb it. Even if you solve the refueling paradox, you're still inside a machine that is pushing chemical propulsion to its ultimate breaking limit. We are at the end of the era of fire and metal. We are trying to use 19th century chemistry, burning things to move them, to conquer a 21st century dream. Every Starship prototype that has disintegrated over the ocean or shattered upon re-entry is a data point in this audit. We see heat shields shedding ceramic tiles like dead skin. We see engines failing to relight in the vacuum. These are not just testing bugs to be patched out. They are the fundamental signals of a species hitting the ceiling of its current technology. The deeper truth that is rarely whispered in press releases is that our current approach to Mars is a fractal of inefficiency. We are building skyscrapers to carry fuel, to carry fuel, to carry fuel. Every extra kilogram of food or water you pack for the crew requires another tanker launch in orbit. Every extra layer of radiation shielding you add to protect their brains requires another 3 rockets from Earth. It is a house of cards built in a hurricane, and we are praying the wind stops just long enough for us to finish the roof. The sheer mass required to keep a human being alive for 3 years in the void is the ultimate weight that is dragging this mission back to the ground. And yet, suppose the miracle happens. Suppose the 20 tankers launch without a single explosion. Suppose every docking is perfect, the cryogenic valves hold, the boil-off is managed, and the tanks of the Mars-bound ship are finally miraculously full. You ignite the engines and push away from the Earth, leaving the cradle behind. You have survived the first wall, but as you move into the deep dark, you realize that the machine you are in is now your entire universe. There is no backup ship. There is no rescue team. You are committed to a trajectory that will take at least 8 months to complete, and there is no turning back. It is during this long, silent transit that the engineering wall gives way to a betrayal that is much more personal. You see, the Starship is a marvel of stainless steel, but to the cosmos, it is a transparent cage. As you move beyond the protection of the Earth's magnetic field, you're stepping into a shooting gallery of high-energy particles that move at 99% the speed of light. The hull that was so strong against the pressure of the atmosphere is practically invisible to the cosmic rays screaming through the void. We have spent decades obsessing over how to power the ship, but we have barely begun to understand how to protect the passengers. This is where the engineering nightmare meets the biological reality. Every kilogram of lead or water you add to shield the crew makes the refueling paradox even more impossible. It is a zero-sum game played with human lives as the stakes, and the math is currently voting against us. We are entering an era where our technical prowess is being audited by the fundamental constants of the universe. We are finding that the Mars goal is a moving target because every solution we find for the rocket reveals a new, more terrifying problem for the human body. The 20-year delay we have seen since the 1950s isn't a fluke of funding or politics. It is the natural result of a species finally seeing the true scale of the obstacle. The refueling paradox is merely the first checkpoint in a gauntlet designed to filter out anyone who isn't ready. As we look at the charred wreckage of our prototypes and the red ink on our balance sheets, we have to ask, are we building a bridge to the future, or are we just staring at a gap that cannot be crossed with fire alone? This is the wall. This is the engineering limit. But as brutal as the refueling math is, it is nothing compared to what happens when you finally reach the end of that journey. Because if you do manage to arrive, you have to find a way to stop. You have to face the thin, treacherous air of a world that doesn't want you to land. You have to survive the most violent sequence of events ever conceived by the human mind. The rocket was only the first thing that could break. The next thing that breaks is the atmosphere itself. Welcome to the 7 minutes of terror. This is where the dream meets the dirt. Suppose the miracle happens. Suppose the 20 tankers launch without a single explosion. The cryogenic valves hold against the absolute zero of the void, and your tanks are finally, miraculously full. You ignite the Raptor engines, leaving the orbit of your home world behind. You have conquered the first wall of engineering. But as the long, silent 8-month transit across the abyss comes to an end, you find yourself staring at a new, more violent reality. You are approaching a world that does not want you to land. For decades, engineers have had a name for the sequence of events that follows. They call it the 7 minutes of terror. And on Mars, terror isn't just an emotion, it is a mathematical certainty. By the time you reach the edge of the Martian atmosphere, you're traveling at 13,000 miles per hour, faster than a rifle bullet, faster than the fastest jet ever forged. You have 7 minutes to go from that blistering hypersonic speed to a dead stop on a surface that has shredded 50% of everything we have ever sent to touch it. This is the second wall of our informed despair. To understand why landing on Mars is getting worse, you have to understand the cruel joke of the Martian atmosphere. It is a ghostly, treacherous layer of carbon dioxide that is the worst of all possible worlds. On Earth, the atmosphere is thick. We can use massive parachutes to slow down almost any payload to a gentle drift. On the Moon, there is no air at all, meaning we can use retro-rockets from start to finish without worrying about aerodynamics or fire. But Mars sits in a lethal middle ground. Its atmosphere is too thin to provide enough drag to stop a heavy spacecraft with parachutes alone, yet it is just thick enough to turn the air in front of your ship into a glowing wall of plasma, reaching 1600 degrees Fahrenheit. You are trying to land a skyscraper on a planet that offers you the friction of a blowtorch, but the buoyancy of a vacuum. Think about the scale of the challenge. Every successful rover we have ever put on Mars, Curiosity, Perseverance, weighed roughly 1 ton. They were the size of small cars, and even they required a terrifyingly complex sky crane maneuver that pushed the limits of robotics. Now look at the Starship. It weighs roughly 200 tons. It is 200 times heavier than any object humanity has ever attempted to land on the red planet. The physics of slowing that much mass through that thin air has never been demonstrated. There are no parachutes in existence large enough or strong enough to catch a falling 40-story building. To survive, the Starship must perform a maneuver that looks more like a frantic, desperate dance than an engineering procedure. It must hit the atmosphere belly first, using its own hull as a giant brake, glowing red in the darkness, before flipping its massive engines at the last possible second to settle vertically on its legs. This moment, the most terrifying variable isn't the heat or the speed, it is the silence. Because of the vast distance between our worlds, a radio signal takes an average of 14 minutes to travel one way. This means that as you begin your descent, you are entirely alone. By the time Mission Control back on Earth receives the signal that you have touched the top of the atmosphere, you have already been dead or alive on the surface for 7 full minutes. There is no pilot in Houston who can save you. There is no manual override. The ship must be its own god, making thousands of split-second decisions, adjusting flaps, calculating wind shear, igniting engines, entirely on its own. It is a 7-minute window where humanity becomes a passive observer to its own survival. We have spent billions on the math, but in these 7 minutes, the math is the only thing that exists. And the history of that math is blood-stained. Engineers half-jokingly speak of the Mars Demon, a localized curse that seems to sabotage missions for sport. But the reality is more mundane and far more chilling. Mars is simply a planet where small, microscopic mistakes cascade into total catastrophe. In 1999, NASA lost the Mars polar lander because a single software glitch shut down the engines too early, dropping the craft to its death from a fatal height. In 2016, the European Space Agency watched their Schiaparelli probe vanish because its computer became confused by the thin air and cut the parachute while it was still miles above the ground. These were small, nimble machines, and they were still obliterated. Now imagine the margin for error when you are trying to balance 200 tons of vibrating steel on a pillar of fire, landing on a surface you have never visited, in a storm of dust you cannot see through. This is where the physical danger of the environment meets the fragility of our design. Mars is not a flat parking lot. It is a world of jagged craters, hidden boulders, and shifting dunes. Starship is a tall, slender vehicle, and tall, slender vehicles have a long, documented history of falling over. The moon is littered with the wreckage of failed landers that tipped at the last second because a leg caught a rock or the ground was softer than expected. If Starship tips even a few degrees during those final seconds, the mission is over. There is no crane to right it. There is no rescue crew to pull the astronauts from the wreckage. A tipped ship is a permanent tomb. And as the engines fire to slow your descent, they kick up a massive, blinding cloud of Martian dust, electrostatically charged, microscopically sharp, and dense enough to blind the very sensors the ship needs to find the ground. You are landing a skyscraper, blind, in a hurricane of glass. Even if the landing is a miracle, even if the legs lock and the ship stands tall, you are not safe, because the goal of Mars exploration is not to die there, it is to come home. And this is the part of the press releases that usually gets skipped. To leave Mars, you need fuel, but the Starship arrives empty. The current plan requires the crew to spend over a year on the surface, operating a robotic chemical factory that must extract water ice from the soil and carbon dioxide from the air to manufacture 1,000 tons of propellant for the return trip. This is a single point of failure of staggering proportions. If the drill jams, if the ice is dirtier than expected, if the solar panels are covered by a global dust storm that lasts for months, the crew is stranded. There is no backup fuel. There is no rescue rocket. You either make your own way out of the gravity well, or you stay until the life support runs out. We are beginning to realize that the 7 minutes of terror doesn't actually end when the engines stop. The terror just changes its shape. You have survived the engineering wall, you have survived the atmospheric trap, and you are standing on the surface of another world. But as the dust settles and the silence of Mars rushes in to meet you, the real betrayal begins. Because you haven't just landed on a planet, you have landed inside a chemical laboratory that is fundamentally incompatible with your biology. The red soil you see through the window isn't just dirt, it is a toxic landscape. We have focused so much on the fire of the rockets and the physics of the landing that we have ignored the silent killers waiting in the dust. The closer we look at the Martian surface, the more we realize that it isn't just a dead world, it is a hostile one. Every breath of recycled air you take, every gram of dust that hitches a ride into the airlock on your suit, and every day you spend under the unfiltered radiation of the sun is a slow, methodical audit of your survival. We are realizing that sending humans to Mars keeps getting worse because we are finally seeing the fine print. We aren't just fighting the vacuum and the gravity, we are fighting a world that is chemically designed to dismantle the human form. As we transition from the fire of the landing to the poison of the surface, remember the scale of what we are attempting. We are trying to force a creature of Earth to exist in a place that has been patient for 4 billion years, waiting for someone to be foolish enough to arrive. The landing was just the front door. Now you have to live inside the house. And as the first explorers will soon find out, the house is made of poison and the air is filled with glass. Welcome to the Chemical Betrayal. This is where the red dust begins its work. You have survived the 7 minutes of terror. The engines have cut out, the dust has settled, and for the first time in history, a human heart is beating on the surface of Mars. But as the adrenaline fades and you look out at the rusted, indifferent horizon, a cold reality begins to set in. You are standing on a world that has no gas stations. You have arrived with just enough fuel to land, and your tanks are now as empty as the desert around you. To leave to ever see an Earthrise again, you must perform a feat of industrial alchemy that has never been attempted outside of a laboratory. This is the third wall of our informed despair. Engineers call it in situ resource utilization, or ISRU. But for the crew on the ground, it is a much simpler, more haunting concept. It is the Sabatier nightmare. The basic chemistry sounds almost elegant. In 1897, a French chemist named Paul Sabatier discovered that if you take carbon dioxide and hydrogen, run them over a nickel catalyst at high temperatures, you get methane and water. On paper, it is a miracle. Mars has an atmosphere made almost entirely of carbon dioxide. If you bring a small amount of hydrogen from Earth, or better yet, extract it from Martian ice, you can manufacture the very propellant that the starship's engines crave: liquid methane and liquid oxygen. This is the cornerstone of every modern Mars mission. Without it, the math of the rocket simply collapses. If you tried to bring all the fuel for the return trip from Earth, your rocket would have to be the size of a mountain, burning so much fuel to lift its own weight that it would never leave the pad. So you are forced to bet your life on a chemical reactor 40 million miles from the nearest repair shop. But as every engineer knows, there is a vast, lethal gap between a laboratory experiment and an industrial reality. To get a starship off the surface of Mars and back to Earth, you don't need a few liters of fuel. You need 1,000 tons, 1 million kilograms of high-grade cryogenic propellant. To produce that much, your chemical plant has to run continuously for over a year, drawing carbon from the thin, freezing air and mining water from a planet that hasn't seen a liquid drop in 4 billion years. This is not just a mission. It is the construction of a city-scale power plant on a world that wants to freeze your equipment solid. And here is the line that most press releases choose to ignore. If even one valve in that factory jams, if one seal fails, if one sensor miscalculates the purity of the intake, the crew has no way home. Read that again. They have no way home. In the world of aerospace engineering, there is a forbidden phrase: single point of failure. It refers to any component whose failure would result in the total loss of the mission and the crew. On Earth, we design these out. We build backups for backups. We ensure that no single bolt or circuit board holds the power of life and death. But the architecture of Mars demands a single point of failure of staggering proportions. The Sabatier plant is the ultimate bottleneck. It is a house of cards where every single card must be perfect for 500 days straight. There is no backup fuel depot in orbit. There is no rescue rocket waiting in the wings. The propellant either gets made on Mars, or the crew stays on Mars until the life support runs out. It is a death contract, signed in the ink of chemical equations. The nightmare begins with the water. To make methane, you need hydrogen. The plan is to find water ice buried beneath the Martian regoliths. Orbital maps tell us the ice is there, shimmering in the radar data like a promise. But maps from orbit are notoriously deceptive. They cannot tell you how deep that ice is, how pure it is, or how much rock and toxic dust is mixed into the frozen layers. To get to it, you must drill. And humanity has a terrible track record with Martian soil. We have sent dozens of probes, but we have never drilled deep. The InSight lander's mole was supposed to burrow 15 feet down. It barely scratched the surface before it became stuck, defeated by soil that was stickier and harder than any model predicted. On a human mission, if your drill hits a layer of unexpected basalt, or if the ice is too fragmented to melt, your fuel factory becomes an expensive pile of junk. You are betting the survival of the species on a drill bit 40 million miles away. Suppose the drill works. Now you have to melt the ice and purify the water. Martian ice is not the clean blue ice of the Antarctic. It is a frozen slurry of silicate and salts. If any of those contaminants make it into the Sabatier reactor, they will poison the catalyst, clogging the system and shutting down production. You need a purification system that works with 100% reliability in a sub-zero vacuum. And then there is the energy. To run a chemical plant and a life support system for a year, you need power. A lot of it. We're talking about a power source equivalent to a small Earth town. The current plan involves acres of solar panels spread across the Martian surface. But Mars is a world of dust. In 2018, NASA's Opportunity rover, a machine that had survived for 15 years, was killed by a single global dust storm. The sky turned black, the sunlight vanished, and the rover's battery simply bled out in the cold. On a human mission, a dust storm isn't just a scientific curiosity, it is a death sentence. If a storm covers your solar panels for a month, the fuel factory shuts down. If the factory shuts down, you miss your 26-month launch window back to Earth. You are then forced to wait another 2 years on a planet with dwindling food and failing equipment. The why it keeps getting worse factor is the realization that we are trying to run an industrial civilization on a world that periodically turns off the lights for weeks at a time. The alternative is nuclear power, small portable reactors like the kilopower systems NASA has been testing. But nuclear power brings its own engineering hell. You have to land radioactive material safely, deploy it far enough from the crew to avoid radiation sickness, but close enough to run power lines. And like everything else on Mars, these reactors have never been tested in a real-world Martian environment long enough to prove they won't fail when the first dust devil rattles their cooling fins. We are piling uncertainty on top of uncertainty, hoping that the Saboteur miracle will hold together just long enough to get the crew off the ground. And then there is the scale of the methane itself. Once you manufacture it, you have to store it. You have to keep 1,000 tons of methane and oxygen at hundreds of degrees below zero for over a year. If your cooling system has a microscopic leak, your return fuel slowly evaporates into the vacuum. This is the vanishing propellant problem. You could spend a year of backbreaking labor making fuel, only to find that your tanks are empty when it's time to leave. The sheer logistical weight of maintaining an industrial fuel farm in a world of toxic dust and sub-zero temperatures is starting to look like a barrier that chemical rockets simply cannot overcome. The deeper we look at the Saboteur plant, the more we realize it is a bridge built of glass. It assumes that the ice is pure, the drills won't jam, the weather will cooperate, and the chemistry will be perfect. But space exploration is the history of things not being perfect. It is the history of O-rings failing in the cold and software glitches crashing landers. On Mars, there is no plan B for the fuel. You are asking a crew of 6 explorers to become industrial chemists, miners, and nuclear technicians in an environment that is actively trying to kill them every second of every day. This is the informed despair of the Saboteur nightmare. It is the realization that to get home, we must succeed at a level of perfection that humanity has never achieved even on Earth. We are taking the most catastrophic single point of failure ever conceived and making it the foundation of our future. And as the engineers run the simulations, the failure rates keep climbing. Because the Saboteur plant doesn't just need water and air, it needs a planet that is willing to cooperate. And as we are about to see, the soil of Mars is anything but cooperative. Because even if the fuel factory works, even if the tanks are full and the engines are ready, the very ground you're standing on is preparing a final chemical betrayal. The water you are mining and the dust you're breathing contain a secret that was hidden from us until the very first probes touched the North Pole. It is a chemical weapon that has been waiting for billions of years to meet human biology. As we move from the nightmare of the factory to the reality of the dirt, we find that the Saboteur plant is the least of our worries. The real enemy isn't the empty tank. The real enemy is the soil itself. Welcome to the Chemical Betrayal. This is where the dust becomes a weapon. For decades, we viewed the red soil of Mars through the hazy lens of romanticism. We saw it in our science fiction as the foundation of a new civilization, a dusty frontier waiting for the first human seeds to be planted. We imagined vast greenhouses, domes of glass where Martian regolith would be transformed into life-sustaining gardens. We thought of it as a dormant world, perhaps a bit barren, perhaps a bit cold, but ultimately a passive stage for our ambition. But in 2008, a small, unassuming NASA probe named Phoenix touched down near the Martian North Pole and performed a simple experiment that shattered this illusion forever. It scooped up a handful of that red dirt and tasted it. The data that flashed back across 40 million miles of void was a biological alarm bell. The soil was not just dead, it was weaponized. This is the fifth wall of our informed despair, the chemical betrayal. Scientists discovered that the Martian surface is saturated with perchlorates, toxic salts that are rare on Earth but make up nearly 0.5% of the Martian soil by weight. To a robot, perchlorates are an interesting chemical anomaly. To a human being, they are an invisible executioner. On Earth, perchlorates are used in the manufacturing of rocket fuel and industrial-grade explosives. On Mars, they are a pervasive toxin that has been accumulating for billions of years under a relentless sun. We used to think the primary challenge of living on Mars was the cold or the vacuum. Now we realize that the very ground beneath our feet is a minefield of industrial-strength poison. The danger of perchlorates lies in their surgical precision. They are designed by physics to attack the most vulnerable part of human metabolism, the thyroid gland. The thyroid is the body's thermostat, the small organ in your neck that regulates how you use energy, how you repair your cells, and how you sustain your life. Perchlorates mimic iodine so perfectly that the thyroid absorbs them greedily, effectively locking out the real nutrients your body needs. The result is a slow, systemic collapse. Hypothyroidism, severe anemia, and a failure to produce the very blood cells needed to survive. Imagine being a pioneer on a distant world, millions of miles from a hospital, while your body's internal engine slowly grinds to a halt because the dust on your boots has shut down your metabolism. And here is the reality that keeps getting worse. The dust gets everywhere. This is the lesson we learned from the Apollo missions. When the astronauts walked on the moon, they found that lunar dust was not like Earth dirt. On Earth, wind and water tumbled dust grains for millions of years, smoothing them into round, soft particles. Mars has wind, but it has had no liquid water for 4 billion years. This means the dust grains on Mars have never been smoothed. They have remained sharp, jagged, and microscopically rough. They are essentially billions of tiny, obsidian knives. Because of the planet's low humidity and thin atmosphere, these particles are electrostatically charged. They don't just sit on the ground, they cling. They cling to fabric, they slip through mechanical seals, and they hitch a ride on every spacesuit that enters an airlock. During the Apollo 17 mission, Harrison Schmitt described lunar hay fever, the irritation, the watering eyes, and the burning throat caused by the few grains of dust that made it inside the lunar module. But lunar dust was merely annoying. Martian dust is a long-term death sentence. The average size of a Martian dust grain is roughly 3 micrometers, about 4% of the width of a human hair. In the world of respiratory medicine, this is known as the sweet spot of damage. Particles larger than 10 micrometers are caught by the nose and throat. Particles smaller than half a micrometer are usually exhaled. But 3 micrometer particles are the perfect size to travel deep into the soft, unprotected tissue of the lungs, where they lodge permanently. Once those jagged, silicate shards are in your lungs, they never come out. They begin a process of chronic scarring known as silicosis, the same disease that has killed coal miners and glass workers for centuries. On Mars, every breath of recycled air becomes an incremental act of self-destruction. The dust doesn't just poison you chemically through the perchlorates, it destroys you physically through the silica. You are breathing in a world of microscopic glass. For a mission lasting 2 or 3 years, the accumulation is inevitable. The informed despair of the 21st century is the realization that we cannot simply wipe our feet at the door. The infiltration of the habitat is not a possibility, it is a mathematical certainty. The challenge of the soil also dismantles the dream of ISRU, making fuel and water on site. As we explored in the Sabatier Nightmare, the plan is to mine Martian ice. But that ice is not pure, it is mixed with this toxic regolith. To use that water, you must first scrub it of every trace of perchlorate. If even a tiny fraction remains, it will corrode the very chemical reactors and life support systems meant to keep the crew alive. We are moving from a mission of exploration to a mission of permanent, high-stakes decontamination. The energy required to purify Martian resources is a hidden tax on the mission that makes the living off the land strategy look increasingly like a fantasy. We are finding that Mars isn't a world to be settled. It is a world to be quarantined. Engineers are desperately testing countermeasures. We are developing electrostatic repellers to push dust away from suits, and specialized airlocks that use powerful vacuums to strip particles from every surface. We are studying iodine supplements to protect the thyroid from perchlorate interference, but none of these technologies has ever been tested on actual Martian dust. Why? Because we have never brought any back to Earth. We are designing shields against an enemy we only know through robotic data. The first humans to land on Mars won't just be explorers. They will be the primary test subjects in a biological experiment with zero margin for error. If our filters are only 99% effective, the 1% that gets through will be enough to ruin a human life within months. This is the psychological weight of the chemical betrayal. It turns the habitat, your only sanctuary in the void, into a compromised space. It turns the very act of stepping outside into a gamble with your respiratory health. Every time an astronaut cycles through an airlock, they are bringing the enemy home. The red dust of Mars is a slow-motion poison, a silent intruder that waits in the seals of your suit and the filters of your lungs. It is the realization that the red planet isn't just a color, it's a warning. The soil is telling us that our biology is an uninvited guest. But the betrayal of the soil is only the visible threat. It is the danger you can see on your boots and feel in your throat. Above the surface, in the thin, ghostly air and the blackness beyond, there is a far more terrifying enemy. It is a threat that doesn't need to be touched to kill. It is invisible, it is silent, and it moves at nearly the speed of light. It is an enemy that passes through walls of steel and laid as if they weren't there. We have spent this section looking at the ground, but to understand why sending humans to Mars keeps getting worse, we must now look up. We must face the sky that offers no protection and the stars that are shooting at us. The perchlorates in the glass dust are the walls of the house, but the roof is missing. And through that missing roof, the universe is firing a relentless barrage of high-energy particles that are designed to dismantle the very blueprint of life. We have survived the landing and we have survived the soil, but now we must face the invisible bullets of the void. We have arrived at the most inescapable barrier of all, the sky that has no magnetic shield. Welcome to the radiation gauntlet. This is where the universe begins to edit your DNA. Hold up your hand. Look closely at the skin, the delicate architecture of your veins, the solid reality of your palm. Right now in this heartbeat, millions of invisible particles are screaming through your flesh. They are traveling at 99% the speed of light, carrying the energy of distant stellar explosions that happened millions of years ago. You cannot see them, you cannot feel them, but they are there, a relentless rain of cosmic artillery. On Earth, you are safe. You are protected by two massive layers of planetary armor, a thick, heavy atmosphere that blocks the majority of incoming radiation, and a powerful magnetic field that acts as a cosmic deflector shield, sweeping high-energy particles into the safety of deep space. But the moment you leave the Earth's cradle for the 8-month journey to Mars, that armor vanishes. You are stepping out of the fortress and into a shooting gallery where the universe has been practicing its aim for eons. This is the sixth wall of our informed despair, the radiation gauntlet. For decades, we treated space radiation as a hurdle to be managed, a risk factor that could be mitigated with enough lead or a faster engine. But as our sensors have moved deeper into the void, we have discovered that the radiation environment between Earth and Mars is not just a challenge. It is a physical barrier that our current biology might not be equipped to survive. We are talking about galactic cosmic rays, or GCRs. These are not the gentle light of the sun. These are the heavy, highly charged nuclei of atoms, iron, magnesium, neon, stripped of their electrons and accelerated to near light speed by the violent deaths of stars in distant galaxies. In the niche of the philosophy of physics, we call these HCE particles, and to the human body, they are the most lethal projectiles in the known universe. Think about the physics of an impact. When a standard X-ray or a solar proton hits your body, it acts like a tiny, localized spark. It might damage a single molecule or cause a minor mutation that your body's repair mechanisms can handle. But an HZ particle is different. Because it is so heavy and moving so fast, it doesn't just hit you, it punches through you. It creates what physicists call a tunnel of damage. As it screams through your cells, it breaks chemical bonds, shatters protein structures, and snaps both strands of your DNA like dry twigs in a storm. Imagine a library where a high-speed bowling ball is fired through the stacks every few seconds, shredding pages and destroying entire volumes of information. That library is your genetic code, and on a journey to Mars, there is no librarian to put the books back together. This brings us to the most brutal paradox of the Mars mission, the shielding betrayal. In our early naive days of space planning, the solution seemed obvious. If the radiation is dangerous, just build a thicker wall. Surround the crew with lead or water or thick layers of polyethylene plastic. But reality is not so forgiving. When a high-energy cosmic ray hits a solid shield, it doesn't always stop. Instead, it collides with the atoms of the shield itself, triggering a nuclear reaction. The heavy particle shatters, creating a secondary shower of neutrons, protons, and gamma rays that spray into the interior of the spacecraft like a shotgun blast. By trying to protect the crew with a thin or moderate shield, you have actually made the environment more lethal. You have turned a single, high-speed bullet into a cloud of jagged shrapnel. To truly stop these particles, you would need a shield of lead meters thick, which would make the spacecraft so heavy it could never leave the Earth's orbit. We are trapped in a mathematical stalemate. To carry the shield, we need more fuel. To carry the fuel, we need a bigger ship. But a bigger ship creates a larger target for the radiation. This is why the Mars problem keeps getting worse. The more we learn about the ferocity of cosmic rays, the more we realize that our best engineering is effectively transparent to the primary threat of the void. And then there is the Sun. While galactic cosmic rays are a constant, slow-motion bombardment from the deep past, our own star is a volatile, unpredictable neighbor. Every few years, the Sun undergoes a solar particle event, a massive eruption of high-energy protons that floods the solar system in a matter of hours. On Earth, these events are harmless light shows in the upper atmosphere, but in deep space, they are death sentences. In August 1972, between the Apollo 16 and Apollo 17 missions, the Sun threw a tantrum of staggering intensity. Had a crew been in transit to the Moon at that moment, tucked inside their thin-walled command module, they would have absorbed lethal doses of radiation within hours. They would have died in the dark, millions of miles from help, as their internal organs began to fail under the weight of an invisible fire. For a Mars crew, the probability of catching a major solar event over a 3-year mission is nearly 100%. The current plan is to build a storm shelter inside the Starship, a heavily shielded closet where the crew would huddle for days or weeks while the solar storm passes. But think about the psychological and logistical horror of that reality. 6 people crammed into a space the size of a bathroom, listening to the radiation detectors scream, knowing that if they step outside to fix a life support leak or check a sensor, they are committing suicide. And even if the shelter holds, the solar storm can fry the ship's sensitive electronics, leaving the crew alive but blind and silent in a crippled vessel. We are asking humans to cross an ocean of fire in a boat made of paper. But the most haunting discovery of the last decade isn't the cancer risk, it's what radiation does to the mind. Recent studies on laboratory animals exposed to simulated cosmic rays have revealed a terrifying phenomenon: cognitive erosion. The brain, it turns out, is unusually vulnerable to the tunnels of damage created by HCE particles. The neurons cannot easily repair themselves. The result isn't a sudden collapse, but a slow, persistent decline in memory, problem-solving, and emotional regulation. Imagine being 6 months into the mission. You are the navigator, and you suddenly realize you cannot remember the procedure for a course correction you've practiced 1,000 times. You look at your commander, and you see the same look of vague confusion in his eyes. You are subtly losing the very cognitive tools you need to survive, and you are doing it in an environment where a single mistake is fatal. This is the space fog, a biological dismantling of the human intellect by the sheer physics of the cosmos. The universe isn't just trying to kill your body, it's trying to delete the person inside it. This is the informed despair of the radiation gauntlet. It reveals that the Earth is not just a planet we live on, it is a biological womb. Our magnetic field and our atmosphere are not just features of our world, they are the external organs of our survival. When we leave them, we aren't just exploring, we are undergoing a slow-motion biological unraveling. We are discovering that the biofence around Earth is much stronger than we ever suspected. It is a physical barrier written in the laws of nuclear physics and the fragility of carbon-based life. Every study we conduct on the International Space Station, which is still partially protected by Earth's magnetic field, is a pale shadow of the reality that waits in the deep dark. We have spent trillions of dollars on the metal problem, the rockets, the fuel, the engines, but we are finding that the meat problem is the one that might finally break the dream. You can build a rocket the size of a skyscraper, you can fill it with methane made from Martian air, and you can land it with the grace of a ballerina. But if the humans inside that rocket arrive with shredded DNA, scarred hearts, and eroding minds, what have we actually achieved? We are moving toward a realization that the human Mars mission might be a biological impossibility. The more we know about the gauntlet, the worse it looks. And as the radiation does its silent work on your genetic blueprint, your body is undergoing another, more visible collapse. Because while the cosmic rays are editing your DNA, the lack of gravity is unmaking your very structure. You are standing in a machine that is a shooting gallery, but you are also standing in a world where your bones are dissolving and your heart is shrinking. The radiation is the enemy from without, but the second betrayal is the enemy from within. We have looked up at the stars and seen the invisible bullets, but now we must look at the mirror and see the shadow of the person we used to be. Welcome to the biological unraveling. This is where the weightless void begins to take you apart, bone by bone. We are creatures of the heavy mud. For 4 billion years, every ancestor you have ever had, from the first single-celled organism in the primordial soup to your own parents, evolved under the relentless, steady pull of exactly one Earth gravity. Every bone in your body is a structural response to that weight. Every valve in your heart is a mechanical solution to pushing blood upward against the drag of the planet. We don't feel gravity because it is the water we swim in. It is the fundamental constant of our existence. But the moment you leave the Earth's cradle for the 8-month journey to Mars, that constant vanishes. And in the silence of the weightless void, your body begins to realize that it no longer knows how to be human. This is the 7th wall of our informed despair, the biological unraveling. It begins almost instantly. Within minutes of entering microgravity, the fluids in your body, the blood, the lymph, the interstitial waters, undergo a massive, chaotic redistribution. On Earth, gravity pulls these fluids toward your legs. In space, they rush toward your head. Astronauts call it the puffy face, bird leg syndrome. Your face swells, your sinuses clog, and your brain suddenly feels a pressure it was never designed to endure. But this is just the surface. Beneath the skin, your internal organs are beginning to float in ways that confuse your nervous system. Your vestibular system, the delicate machinery of your inner ear that tells you which way is up, suffers a total breakdown. You spend the first week of your journey in a state of chronic nausea, your brain desperately trying to make sense of a world where up no longer exists. But as the weeks turn into months, the unraveling moves from your senses to your very structure. Your skeleton, the rigid framework that defines your form, begins to dissolve. In the absence of gravity's constant stress, your body decides that your bones are an unnecessary luxury. You begin to lose bone mineral density at a rate of roughly 1% per month. To put that in perspective, an elderly woman on Earth suffering from severe osteoporosis loses about 1% of her bone density in a year. On the way to Mars, you are aging your skeleton by a decade every 30 days. By the time you reach the red planet, you have the bones of a 90-year-old. And where does that dissolved bone go? It leaks into your bloodstream. You are effectively suffering from a slow-motion overdose of your own skeletal calcium. This flood of mineral waste puts an enormous strain on your kidneys, leading to the formation of agonizing kidney stones. Imagine being 6 months into a mission, 40 million miles from the nearest surgical suite, passing a jagged shard of calcium through your system while floating in a vacuum. This isn't just a medical risk, it is a mission-ending catastrophe. We are discovering that the human machine cannot simply be moved from one gravity well to another. It begins to dismantle its own foundation the moment the weight is lifted. While your bones are turning to liquid, your heart is turning to shadow. Your heart is the most reliable pump ever forged by nature, but it is a reactive muscle. On Earth, it fights every second of every day to push blood against the 1G pull of the planet. In the weightlessness of the starship, that fight is over. The heart becomes lazy. It no longer has to work to get blood to the brain. And like any muscle that isn't used, it begins to atrophy. It shrinks. It actually changes its physical shape, moving from a powerful, elongated muscle to a smaller, more spherical, and far less efficient pump. We are realizing that the Martian explorer isn't a hero of myth. They are a biological prisoner whose very engine is withering away during the journey. But the most terrifying betrayal discovered in the last decade is something that happens to the eyes. It is called SANS, Spaceflight-Associated Neuroocular Syndrome. Because of the fluid shift toward the head, the pressure inside the skull increases dramatically. This pressure pushes against the back of the eyes, actually flattening the eyeball itself. It causes the optic nerve to swell and creates choroidal folds in the delicate tissue of the retina. The result is a persistent, worsening blurriness of vision. Think about the horror of this reality. You have spent billions of dollars and 8 months of your life to reach the red planet. You are the navigator, the person responsible for the final, lethal landing. And as the planet grows large in the window, you realize you can no longer see the instrument panel. You can no longer focus on the horizon. Your eyes, fine-tuned for Earth's gravity, have been crushed by the physics of the void. We have found that for some astronauts, this damage is permanent. They return to Earth with vision that never fully recovers. We are sending humans to see a new world, but the journey itself is taking their sight. And then there is the enemy within, the microbiome. Your body is not just you. It is a walking ecosystem, home to trillions of bacteria and viruses that regulate your digestion, your immune system, and even your mood. In the closed, recycled, and irradiated environment of a spacecraft, this ecosystem undergoes a dark transformation. Studies on the International Space Station have shown that bacteria become more virulent in space. They grow thicker cell walls and become more resistant to antibiotics. At the same time, the human immune system becomes confused. It enters a state of dysregulation. Parts of your immune system become overactive, leading to strange rashes and allergies, while the parts that fight viruses become dormant. This is when the ghosts wake up. Almost every adult human carries latent viruses like herpes or shingles, kept in check by a healthy immune system. In the stress and radiation of a Mars mission, these viruses reactivate. They wake up and begin to move through the crew. Imagine a 6-person habitat where everyone is suffering from erupting rashes, blurred vision, atrophied hearts, and dissolving bones, all while their internal bacteria are evolving into antibiotic-resistant strains. This is the reality that the CGI animations never show you. This is the informed despair of the 21st century. We are realizing that we are not just sending humans to Mars. We are trying to force a deep-sea fish to live on a mountaintop. We are biological properties of Earth. We are tethered to this planet by a billion years of evolutionary code that we cannot simply program our way out of. Every exercise machine on the starship, every resistance band, and every dietary supplement is a desperate, pathetic attempt to trick a body that knows it is in the wrong place. We have spent 70 years obsessing over the physics of the rocket, but we are finding that the physics of the meat is the ultimate barrier. As you look at the red horizon of Mars after 8 months of this unraveling, the question isn't whether you can walk on the surface. The question is whether you can even stand. When you finally experience Martian gravity, which is 38% of Earth's, it won't feel light. It will feel like a crushing weight to a body that has forgotten what weight is. Your bones are brittle, your muscles are thin, and your heart is unsteady. A simple stumble on a Martian rock could result in a shattered hip that will never heal. A minor infection could become a systemic failure that your dysregulated immune system cannot fight. The why it keeps getting worse factor is the realization that the more we study the human body in space, the more limiters we find. In the 1960s, we thought a few months in orbit was fine. In the 1990s, we realized bone loss was a problem. In the 2010s, we discovered the eye-flattening syndrome and the genetic shifts. We are discovering that the biofence around Earth is not a single wall, but a series of concentric circles, each more difficult to cross than the last. We are finding that the human form might have an expiration date in the void, a point beyond which the unraveling becomes irreversible. And this leads us to the most haunting realization of all, the aging paradox. Because while your heart is shrinking and your bones are dissolving, something even stranger is happening to your very timeline. We are finding that spaceflight doesn't just damage the body, it edits the clock of life itself. We discovered this through a unique experiment involving 2 identical men, one who went to the stars and one who stayed behind. And what we found in their DNA suggests that the first person to reach Mars might arrive as a biological ghost of the person they used to be. We have seen the body collapse in the present, but now we must look at how space flight steals the future. We must look at the genetic crash that happens when a creature of the mud tries to live among the stars. Welcome to the aging paradox. This is where we find out that the price of the red planet is your own time. Time is the only currency the universe never refunds. We spend it blindly, assuming that our bodies are stable vessels, that a year is a year, and that our identity is written in the permanent ink of our DNA. But as we push further into the Mars problem, we are discovering that the laws of physics do not just govern the trajectory of rockets, they govern the clock of life itself. We are finding that space travel doesn't just damage the body, it edits the biological timeline. It creates a rift in the very essence of who we are. This is the 8th wall of our informed despair, the aging paradox. For decades, we suspected that the void would be hard on us, but it wasn't until 2019 that we realized it was actively unmaking our genetic future. To understand this betrayal, we have to look at a unique moment in human history, the NASA twin study. In 2015, NASA sent astronaut Scott Kelly to the International Space Station for 340 consecutive days, while his identical twin brother Mark Kelly, also an astronaut, remained on Earth. It was the perfect scientific setup. 2 men with identical genetic blueprints, separated by the boundary of the atmosphere. One stayed in the protection of the cradle, the other stepped into the radiation and weightlessness of the vacuum. Scientists wanted to know if the person who returned from the stars would still be the same person who left. What they found was a biological mystery that sounds more like science fiction than medicine. The mystery begins with a structure called a telomere. Think of your DNA as a long, intricate shoelace that contains the instructions for everything you are. At the very ends of those laces are protective plastic caps called telomeres. Their job's to keep your genetic code from fraying. Every time your cells divide, these caps get a little bit shorter. This is the fundamental mechanism of aging. When your telomeres get too short, the cell can no longer divide and the body begins to fail. It is the biological hourglass of our species. We expected that the stress, the radiation, and the recycled air of space would accelerate this process, that Scott would return older than Mark. But the universe offered a cruel, deceptive twist. While Scott was in space, his telomeres didn't shorten, they grew. The headlines at the time were ecstatic. They spoke of a fountain of youth in orbit. They suggested that space travel might actually slow down the aging process, that perhaps we were destined to be a long-lived, multiplanetary species. It felt like a gift from the cosmos, a sign that we belonged among the stars. But as the mission ended and Scott returned to Earth, the gift was revealed to be a mirage. Within 48 hours of touching the ground, Scott's telomeres underwent a catastrophic collapse. They didn't just return to normal, they shortened dramatically, becoming significantly smaller than his brother Mark's. The youth he had gained was actually a desperate, high-stakes stress response, a biological emergency mode, where the body was frantically trying to shield itself from the radiation and the vacuum. When the dust settled, Scott Kelly had biologically aged more than his twin who stayed on Earth. He had returned as a genetic ghost, his biological clock accelerated by the very journey that had promised him immortality. This is the reality of the Mars mission that keeps getting worse. We are discovering that the human body doesn't just endure space, it pays for it with its future. A 3-year trip to Mars isn't just a 3-year commitment, it might be a 10-year tax on your lifespan. We are asking explorers to trade their old age for a glimpse of a red desert. But the unraveling goes deeper than the caps on our DNA. It moves into the very way our genes express themselves. Your DNA is a static library, but your gene expression, the way your body actually reads those books, is dynamic. It changes based on your environment, your diet, and your stress. During his year in space, 7% of Scott Kelly's gene expression changed so radically that it didn't return to baseline when he came home. Thousands of genetic switches were flipped by the radiation and the low gravity, and years later they remain flipped. His immune system, his bone formation, and his metabolic pathways are permanently altered. In a real, measurable way, Scott Kelly is no longer genetically identical to his twin. The space has rewritten him. Now apply this to the Mars mission. Scott was in low Earth orbit, still partially protected by the Earth's magnetic field for only 1 year. A Mars crew will be in deep space, exposed to the full, unfiltered rage of galactic cosmic rays for 3 years. If 1 year in the cradle can permanently alter 7% of your genetic expression, what does 3 years in the void do? We are looking at a future where the people who return from Mars are no longer fully human in the way we understand the term. They will be a new, mutated branch of the species, their biology scarred and edited by a world that never wanted them there. We are realizing that the biofence around Earth isn't just about oxygen and water, it's about the very stability of our genetic identity. And the collapse is not just genetic, it is structural. During the twin study, Scott's carotid artery, the main highway of blood to the brain, thickened significantly. His body was suffering from a form of space-induced cardiovascular disease that resembled the aging of an 80-year-old man. His cognitive accuracy dipped. His mental flexibility slowed. This is the informed despair of the 21st century. We are finding that every system in the human machine has a failure point, and the Mars mission pushes all of them simultaneously. We are sending the best and brightest our species has to offer, and we are receiving them back as shadows of their former selves. This leads us to a profound philosophical question that touches on the niche of cosmic consciousness. If our DNA, the very code of our life, is so dependent on the specific gravity and magnetic field of Earth, does that mean our consciousness is also earthbound? We like to think of our minds as independent entities that can travel anywhere, but what if our awareness is a function of our local reality? If your DNA frays and your gene expression shifts, does the you inside the body change too? Are the explorers who land on Mars even the same conscious entities who left Earth, or has the journey edited their very souls? We are finding that the universe doesn't just bar our way with physics and fire, it bars our way with the laws of information. We are Earth-based information systems, fine-tuned over eons to operate within a very narrow set of parameters. When we leave those parameters, the information begins to corrupt. We are like a piece of software designed to run on a specific operating system, trying to force ourselves to run on a hardware that is fundamentally incompatible. The bugs aren't just bone loss and radiation. The bugs are the systematic dismantling of the human blueprint. The why it keeps getting worse factor is the realization that there is no engineering fix for this. You can't shield your way out of a genetic crash. You can't exercise your way out of altered gene expression. We are hitting the absolute limits of carbon-based life. The dream of a Martian colony assumes that we can just move to another planet, but we are discovering that we are not passengers. We are part of the ship. We are part of the Earth. To move to Mars isn't like moving to a new house. It's like trying to move a coral reef into a swimming pool. The life might survive for a moment, but the system will eventually collapse because it has been severed from the context that makes it possible. As we look at the red horizon of Mars, we have to face the ultimate price. We have survived the refueling, we have survived the landing, we have survived the toxic soil, and we have survived the radiation. But as you stand on that rusted dirt, you have to realize that you are no longer the person you were when you left. You are a biological ghost, your timeline accelerated, your DNA edited, and your future stolen. You have reached the goal, but you have lost the self. The aging paradox is the final, quiet audit of our ambition. It is the universe telling us that some places are not meant for us, and the cost of entry is everything we are. But as your body and your genes unravel in the Martian silence, something else is happening. Something far more immediate and far more dangerous. Because while your DNA is fraying, your mind is beginning to fracture. We have talked about the meat and the code, but we have not yet talked about the silence. Because the greatest threat to a Mars mission isn't the radiation or the bone loss, it is the absolute, crushing isolation of the void. It is the realization that you are further from home than any human has ever been. And the Earth is nothing more than a tiny, indifferent blue spark in a sky that doesn't care if you live or die. Welcome to the psychological abyss. This is where the mind begins to break. The human mind is a creature of the social fire. For 250,000 years, our consciousness has been forged in the heat of communal survival, the rhythm of shared stories, and the constant, comforting feedback of a living world. We are neurologically wired for the now, for the immediate response of a loved one's voice, the instant feedback of a physical touch, and the unwavering presence of the horizon that birthed us. But as we push toward the red planet, we are discovering that the greatest threat to the mission isn't the radiation that shreds our DNA or the low gravity that dissolves our bones. It is the absolute, crushing silence of the abyss. It is the realization that the mind, much like the body, might be a property of the Earth, and when you cut the psychological umbilical cord, the self begins to fracture in ways we are only just beginning to understand. This is the ninth wall of our informed despair, the psychological abyss. To understand the horror of this isolation, you must first understand the scale of the distance. When the Apollo astronauts traveled to the moon, they were never truly gone. They were only 3 days from home. If they looked out the window, the Earth was a massive, luminous marble, filling their field of vision with the familiar blues and whites of life. They were tourists in the backyard of their home world. But a journey to Mars is not a trip, it is an exile. As the starship burns its engines and pushes into the deep dark, the Earth does not stay a companion. It begins to shrink. It fades from a world to a marble, then to a coin, and finally to a tiny, indifferent blue spark that is indistinguishable from the distant stars. This is the Earth out of view phenomenon, and psychologists believe it is the single most dangerous trigger in the history of human exploration. When the Earth vanishes, the primary anchor of human sanity goes with it. We are finding that the human ego is not a self-contained unit. It is a system that requires the constant calibration of a home world. Without the visual confirmation of Earth, the mind enters a state of existential vertigo. You are no longer from anywhere. You are a ghost in a tin can, floating in an infinite black graveyard where the nearest rescue is 40 million miles and 8 months away. This isn't just homesickness. This is the systematic dismantling of the spatial and emotional frameworks that keep us sane. We are finding that the why it keeps getting worse factor is the realization that we cannot simply train astronauts to be lonely. We are fighting 250,000 years of neurobiology that tells us that isolation equals death. And then there is the betrayal of the now. In the niche of the philosophy of physics, we talk about the speed of light as the universal limit of information. On Earth, we live in a world of instant communication, but on the way to Mars, the speed of light becomes a psychological prison. At its furthest point, a radio signal takes 22 minutes to travel from Mars to Earth. This means that a simple conversation, "Hello, how are you?" takes 44 minutes to complete. This delay is the death of human connection. You cannot have a conversation with your family, you can only exchange video letters with the dead. You are no longer part of the human timeline. If a crisis happens on Earth, you hear about it after it is over. If you have a crisis on the ship, the advice from Houston arrives long after you have either solved the problem or died trying. This creates a state of temporal isolation. The crew becomes a closed system, a tiny island of now in a vast sea of then. And history shows us exactly what happens to humans when they are trapped in a closed system with no escape. We have seen it in the Mars 500 experiment, where 6 volunteers were locked in a simulated habitat for 500 days. We have seen it in the Antarctic research stations during the long, dark winter rovers. The results are a chilling audit of the human spirit. Within months, the simulation begins to feel like a cage. Sleep cycles break. Clinical depression sets in. One participant in the Mars 500 study spent nearly the entire mission in a state of hibernation-like withdrawal, barely eating, barely speaking, moving through the ship like a specter. Another developed insomnia so severe that his cognitive performance dropped to the level of a sleep-deprived drunk. But the most dangerous transformation is the social one. In a closed system, small irritations don't just fade, they become weaponized. The way a crewmate chews their food, the sound of their breathing, the repetitive nature of their stories, these become triggers for a primal simmering rage. We have seen Antarctic crews stop speaking to each other for months, divided into silent, hostile factions. On a Mars mission, there is no outside to go to. There is no escape. You are locked in a pressurized box with the same 5 people for 3 years, knowing that your life depends on them, even as you grow to loathe the very sound of their voices. The informed despair of the 21st century is the realization that the mind fractures under these conditions in predictable, lethal patterns. We are sending a crew of heroes, but the void is designed to turn them into enemies. This leads us to the deep mystery of cosmic consciousness. Some philosophers of science suggest that the human mind is not just a brain in a skull. It is an entity that exists in resonance with the planetary environment. We evolved with the 24-hour cycle of light and dark, the changing of seasons, and the subtle magnetic and gravitational frequencies of Earth. On Mars, every one of these frequencies is wrong. The Martian day is 37 minutes longer, a slight shift that over months completely desynchronizes the human circadian rhythm, leading to chronic fatigue and cognitive decline. The frequency of life is missing. We have to ask, does consciousness require a planet to stay stable? Can a mind survive when it is severed from the biological motherboard of Earth? The deeper we look at the psychological data, the more it seems that we are trying to perform a surgical separation that the patient cannot survive. We are trying to take a social, earthbound animal and turn it into a solitary, cosmic monk. The Refueling Paradox was about the physics of fuel, but the psychological abyss is about the physics of the soul. We are finding that the mind has a breaking strain, just like a steel beam, and the Mars mission exceeds that strain by every measurable metric. The silence of the void is not empty, it is a weight that presses against the ego until it buckles. We are sending humans to the red planet, but we are finding that the person who arrives might not be the person who left. As you stand on the surface of Mars, looking at that tiny blue spark in the sky, the isolation becomes absolute. You have survived the engineering, the landing, the toxic soil, the radiation, and the genetic crash. But as you stand there, millions of miles from the nearest breath of fresh air or the sound of a bird, you realize that you are the most alone human being in the history of the species. You have reached the destination, but you have lost the world. The psychological abyss is the final, crushing audit of our ambition. It is the realization that we are not built for the stars, we are built for the mud. And the further we go from the mud, the more we lose of ourselves. But as the mind fractures and the ego dissolves in the Martian silence, there is one final enemy waiting to meet you. It is an enemy that doesn't care about your DNA or your sanity. It is an enemy that has been waiting for every visitor we have ever sent to the Red Planet. It is the history of the missions that never made it, the ghosts of the machines that came before you. Because as we are about to see, Mars is not just a destination, it is a graveyard. And the demon that guards that graveyard has a very long memory. Welcome to the Mars Demon. This is where we look at the history of failure and the chilling reality of why, even with our best technology, the Red Planet still says no. In the windowless rooms of NASA's Jet Propulsion Laboratory and the hushed corridors of the Russian Space Research Institute, there is a ghost story that engineers tell with a straight face. They call it the Mars Demon. It is a half-joking, half-terrified personification of the statistical nightmare that is the Red Planet. To the public, space exploration is a triumphant march of progress, a series of giant leaps and historical firsts. But to those who actually build the machines, Mars is not a destination, it is a graveyard. It is a world that has swallowed more human ambition, more taxpayer wealth, and more years of scientific labor than any other point in the solar system. This is the 10th wall of our informed despair, the history of failure. If you want to know why sending humans to Mars keeps getting worse, you have to look at the wreckage of the robots that went before us. You have to face the fact that even without a human heart on board, our success rate is essentially a coin flip. The Mars Demon first began its work in the 1960s, during the fevered dream of the Cold War. While the United States and the Soviet Union were locked in a race for the moon, a much quieter, more brutal war was being fought over Mars. Between 1960 and 1964, the Soviet Union launched 6 consecutive missions to the Red Planet. Not a single one succeeded. Some exploded on the pad, others became silent derelicts in Earth orbit, one vanished in the deep dark of interplanetary space. The Soviets, masters of engineering and sheer persistence, threw everything they had at the red dot in the sky, and Mars simply wiped them from the scoreboard. It was a massacre of technology that set the tone for the next 60 years. We think of Mars as a new frontier, but it is actually the most consistent site of human defeat in the history of exploration. When success finally came, it was brief and haunting. In 1971, the Soviet Mars 2 lander became the first human-made object to touch the surface, but it didn't land. It crashed, leaving a new crater as its only legacy. Weeks later, Mars 3 managed the impossible, a soft, controlled landing in the middle of a global dust storm. It began to beam back data, the first transmission from the surface of another world. The scientists in Moscow held their breath. The image began to resolve, and then after exactly 14 seconds, the signal went dead. Mars 3 became a permanent, silent monument in the red dust. Those 14 seconds represent the total sum of decades of Soviet landing attempts. It is a chilling reminder that on Mars, almost is the same as never. The demon doesn't negotiate, it waits for the smallest crack in the math, the tiniest vibration in the sensor, and it takes everything. As we move into the modern era, the failures haven't stopped. They have simply become more expensive and more embarrassing. In 1999, NASA suffered a double heartbreak that remains the gold standard for informed despair. First, the Mars Climate Orbiter, a $125 million spacecraft, burned up in the Martian atmosphere because one engineering team used metric units while another used imperial. A simple unit conversion error, a mistake a high school student could make, was enough to turn years of work into a meteor. Months later, the Mars Polar Lander vanished during its final descent. It is believed that a software glitch mistook the vibration of the landing legs for the actual touchdown, shutting off the engines while the craft was still 40 feet in the air. It fell to its death in the silence. This is the why it keeps getting worse factor. Mars is a planet that rewards perfection with nothing and punishes the slightest human error with total destruction. On Earth, if a car's software glitches, you pull over. On the way to Mars, if a line of code is wrong, you become a billion-dollar firework. We are trying to perform the most complex technical feat in history with a species that is fundamentally prone to small, stupid mistakes. We have lost missions from the United States, Russia, the European Space Agency, Japan, and China. We have lost them to propellant lakes, to parachute tangles, to dead batteries, and to pure, unexplained silence. When you total the numbers, the historical success rate for Mars missions sits at roughly 50%. Imagine boarding a flight where every second seat is a death sentence. That is the statistical reality of the red planet. But why is Mars so much harder than the Moon? In the niche of the philosophy of physics, we look at the coupling of complexity. On the Moon, the variables are limited. There is no air, so there is no weather, no unpredictable drag, and no heat shield. You just point a rocket down and fire. But Mars, as we saw in the 7 Minutes of Terror, is a chaotic system. Its atmosphere is variable. A dust storm on the other side of the planet can change the density of the air at your landing site, throwing off your descent calculations. The terrain is a maze of jagged basalt and soft sand that can swallow a lander's leg or tip a skyscraper-sized rocket. Mars is a dynamic opponent that reacts to your arrival. It is an environment where small mistakes cascade, a term engineers use to describe how a single loose bolt or a stray bit of dust in a valve can trigger a total systemic collapse. This leads us to a profound philosophical realization. Maybe we aren't built to operate at the level of precision Mars requires. We like to think of ourselves as a technological species, but we are still biological entities governed by fatigue, distraction, and ego. The Mars demon is not a ghost, it is the mirror. It is the manifestation of human limitation when confronted with the cold, absolute laws of a hostile universe. We are finding that as our machines become more complex, the number of failure modes grows exponentially. A 1960s probe had a few hundred parts that could break. A starship has millions. By building bigger and more complex systems to solve the Mars problem, we are actually creating more doors for the demon to walk through. We are moving toward a point where the probability of a perfect mission begins to approach zero. Think about the psychological weight of this history for the crew. You are 6 months into the journey, and you are constantly aware of the ghosts of the machines that came before you. You know that half of the missions to this world have failed. You know that a single metric to imperial error killed a previous orbiter. You know that the dust you see in the distance has killed rovers and buried landers. You are living inside a historical record of catastrophe. The informed despair isn't just about the radiation or the bones. It is the crushing weight of the odds. We are asking humans to bet their lives on a coin flip where the demon has been winning for 60 years. The deeper we look at the wreckage, the more we have to ask a radical question. If Mars is a graveyard for our best technology, if it is a world where human error is a death sentence, then why are we still trying to send humans at all? We have seen that the robotic missions that do asterisk succeed are the ones that have revolutionized our understanding. Our rovers have tasted the soil, heard the wind, and seen the sunsets. They don't need food, they don't have DNA to shred, and they don't suffer from the silence. This brings us to the most uncomfortable shift in the modern Mars conversation. While we have been obsessing over the heroic explorer, a different kind of explorer has been quietly evolving. We are finding that the why it keeps getting worse factor for human missions is the realization that we might already be obsolete. The robots aren't just the scouts, they might be the only ones who actually belong there. We have spent this section looking at the failures of the past, but now we must look at the successors of the future. We must face the possibility that the first Martians aren't going to be people of flesh and blood, but entities of silicon and code. Welcome to the robotic obsolescence. This is where we ask, if the demon can be defeated by a machine, why would we ever risk a soul? In the late months of 2025, while the world was still reeling from the quiet cancellation of the human 2026 Mars window, a different kind of passenger was being prepared for the journey. It didn't need a pressurized cabin. It didn't need 1,000 tons of recycled water or a shield against the DNA-shredding fury of galactic cosmic rays. It didn't have a thyroid to be dissolved by perchlorates, nor a mind that would fracture in the absolute silence of the void. It was an entity of silicon, lithium, and code, a humanoid robot designed to walk, manipulate tools, and feel the Martian wind with sensors far more precise than human skin. As we look at the rising capabilities of artificial intelligence and the resilience of our mechanical proxies, we are forced to confront the 11th wall of our informed despair: robotic obsolescence. The reason sending humans to Mars keeps getting worse is that every year, the human part of the mission becomes less of a scientific necessity and more of an expensive, lethal burden. For 70 years, the justification for sending people to the Red Planet was based on a simple, undeniable fact. Humans are smarter than machines. We have intuition. We have the ability to make split-second judgment calls. We have field experience, the capacity for a geologist to look at a rock and see 1 billion years of history that a robot would miss. In the 1970s, a rover was a glorified radio on wheels that could barely navigate a flat floor. But that gap is closing with terrifying speed. Today, we have rovers like Perseverance that are autonomous laboratories, capable of selecting samples, navigating jagged terrain without help from Earth, and flying helicopters in a thin, alien atmosphere. And now, we are entering the era of the humanoid. When machines like Tesla's Optimus or NASA's Valkyrie reach the level of general intelligence, the last remaining reason for human presence, our cognitive flexibility, simply evaporates into the vacuum. Think about the cold, hard mathematics of the mission. To send a single human to Mars, you must launch a spacecraft the size of a 40-story building, filled with life support machinery that is prone to catastrophic failure. You must solve the refueling paradox, survive the radiation gauntlet, and hope the Sabatier factory doesn't jam. You are spending hundreds of billions of dollars to keep a fragile biological entity from dying for 3 years. But for the same cost and mass, you could send 1,000 robots. You could seed the entire planet with eyes and hands that never tire, never sleep, and never need a return ticket. This is the efficiency gap. We are finding that the cost of carrying the soul to Mars is so high that it actually prevents us from doing the science. Every kilogram of food we pack for an astronaut is a kilogram of sensors we leave behind. And then there is the politics of death. In the niche of the philosophy of physics, we explore the concept of civilizational risk. If a robotic rover crashes on Mars, it is a headline for a day, a line item in a budget report, and a disappointment for a team of scientists. But if a human crew, 6 of our best and brightest, is incinerated on re-entry or left to starve in the Martian dark because a fuel valve jammed, it is a civilizational trauma. It is a tragedy that can shut down a space program for a generation. We saw it with Challenger. We saw it with Columbia. The risk of losing a human soul on Mars is so politically and emotionally devastating that it has become the ultimate braking force on exploration. Robots, however, can be sacrificed without grief. They can be sent into the most dangerous craters. They can be used to test lethal landing maneuvers, and they can be left to die in the dust when their batteries finally fail. The Mars demon loses its power when there is no life to steal. This leads us to a profound and uncomfortable philosophical question. Is the dream of humans on Mars just a sales pitch? For decades, visionaries have used the image of the human footprint to raise capital, to win votes, and to sell a romantic vision of a multiplanetary future. We are told that we must go because it is our destiny, because it is the backup for the species. But as we have seen, Mars is not a backup, it is a graveyard. And the human frontier is starting to look like a marketing illusion designed to sustain a 20th century myth. We are a species obsessed with the self, and we cannot imagine a future in space that doesn't involve our own biological presence. but the universe doesn't care about our ego. It is a place of radiation, vacuum, and vast time, an environment that is fundamentally built for machines, not for meat. We have to ask, who are the real Martians? If a robot can live on the surface for 20 years, conducting research, building infrastructure, and sending back high-definition data that allows us to experience the planet via virtual reality, hasn't the mission already been achieved? If we can feel the red sand through a haptic suit on Earth, do we really need a physical foot to touch it? We are entering an era of proxy exploration, where our consciousness is expanding into the solar system through our mechanical children. The why it keeps getting worse factor is the realization that the human body is becoming an obsolete vessel for our ambition. We are trying to force a one biological system to perform a 5 cosmic task. This brings us to a chilling speculative horizon. Some thinkers suggest that humanity is merely the bootloader for artificial life. In this view, our entire biological history, our evolution from the mud, our discovery of fire, our invention of the rocket, was just a preliminary step to create a form of life that actually belongs in the stars. We are the fragile, short-lived caterpillars of the cosmos, building the silicon cocoons from which the real spacefarers will emerge. If this is true, then our struggle with the Mars problem isn't a failure, it's a transition. The reason sending humans to Mars keeps getting worse is that we are trying to do something that we were never meant to do. We are trying to take the bootloader into the final operating system. But there is a resistance to this idea. It comes from the soul of the mission. There is a deep, primal part of us that believes a human presence is what makes exploration meaningful. We want to see a human face reflected in a Martian visor because we want to know that we were there. We want to hear a human voice crackle across the 40-minute delay because it proves that our consciousness can inhabit other worlds. But is that desire for meaning enough to justify the biological wreckage we have explored in these sections? Is a photo op of a human bootprint worth the dissolved bones, the blinded eyes, and the frayed DNA? Or are we simply a species that refuses to accept its own limitations? The informed despair of the 21st century is the realization that our ambition has outpaced our biology. We have designed machines that can conquer the stars, but we are still the same creatures who huddled around fires in the caves of Earth. We are finding that the Mars wall is not just a wall of physics, it is a wall of identity. We have to decide if we want to be the species that actually goes asterisk to Mars, or the species that experiences Mars through its creations. And as the timelines for human missions continue to slide, the universe is slowly forcing us toward an answer. The Mars demon is currently laughing at our skyscraper-sized rockets, but it has no answer for the silent, patient robots that are already living in its graveyard. As we look at the red horizon one final time, we have to face the ultimate conclusion. We have looked at the fuel, the landing, the soil, the radiation, the bones, and the mind. We have seen how the universe rejects the human form at every level, and now we see that even our replacement is ready. This is the final audit. The why it keeps getting worse factor isn't just about the technology, it's about our place in the cosmic hierarchy. We are finding that the red planet might be the great filter, the physical barrier that decides which civilizations stay home and which ones evolve beyond their biological cradles. We have arrived at the end of the journey. We have moved from the atomic hope of 1952 to the cosmic realism of today. And as we close this audit, we must ask the final, most haunting question of all. If we cannot cross the gap to Mars, if the radiation, the biology, and the machines all conspire to keep us on this one blue marble, what does that say about the fate of the universe? Are we the first ones to hit this wall? Or is the sky silent because every civilization before us eventually looked at their own Mars problem and realized the answer was no? Welcome to the Great Filter. This is where the dream of Mars meets the reality of the silence. We began this journey by looking at a fireball over the Caribbean and a series of broken promises. We have traveled through the engineering walls of the Refueling Paradox, the chemical betrayal of the Martian soil, and the biological unraveling of the human form. We have seen how our bones dissolve, our eyes flatten, and our DNA frays like an unraveling shoelace in the face of cosmic radiation. And now, we find ourselves standing at the edge of the ultimate mystery, a question that has haunted the niche of the philosophy of physics for nearly a century. If the universe is as vast as our telescopes suggest, and if the ingredients for life are as common as our chemistry tells us, then why is the sky so silent? Where is everybody? This is the 12th and final wall of our informed despair, the Great Filter. In 1950, Enrico Fermi asked that simple question, and the silence of the stars has been the only reply. Some thinkers suggest that the reason we don't see galactic civilizations is because every species eventually hits a wall. They hit a barrier so high, so hostile, and so fundamentally incompatible with biological life that no amount of technology can overcome it. As we look at the mounting evidence of the Mars problem, the way every solution reveals 3 new nightmares, we have to confront a terrifying possibility. Maybe Mars isn't just a destination we haven't reached yet. Maybe Mars is the filter. Perhaps the universe has built a biofence around every cradle of life. Maybe the laws of radiation and the fragility of carbon-based DNA are not just hurdles, but a permanent quarantine. We have spent 70 years thinking that we were destined to be a multiplanetary species, but we are finally becoming smart enough to see the cage. We are discovering that we aren't just on Earth, we are a functional part of its specific magnetic and gravitational frequency. We are finding that the further we go from the mud of our home, the less human we become, until the entity that reaches the stars is no longer the entity that left the planet. This is why it keeps getting worse. In the 1950s, our ignorance was our greatest source of hope. We didn't know about the HCE particles or the perchlorates or the sand syndrome. We thought the universe was an empty room waiting for us to walk in. But as we have filled that room with our sensors and our data, we have realized that the room is filled with invisible fire and toxic dust. The informed despair of the 21st century is the realization that the more we know about the red planet, the more it whispers a single, devastating word back to us: no. Does this mean the dream is a failure? In a purely scientific sense, perhaps. If the goal is a self-sustaining human colony on Mars within our lifetimes, the data suggests that we are chasing a mirage. But in a philosophical sense, there is a different kind of triumph. We have undergone a cosmic audit. We have tested the limits of our ambition against the absolute constants of the universe. We have learned that we are more fragile than we thought, but we have also learned that our home, this one blue marble, is more precious than we ever dared to imagine. The Mars problem has acted as a mirror, reflecting our own limitations and the incredible uniqueness of our biosphere back at us. We are finding that we might be a single-planet species by design, not by choice. And there is a strange, haunting beauty in that humility. If Mars is indeed the wall, if it is the great filter that keeps us locked in our cradle, then every breath of fresh air on Earth, every heartbeat in 1G, and every year of life protected by our magnetic shield is a miracle of staggering proportions. We are not just biological accidents. We are the only part of the universe that has figured out how to survive itself, at least for now. As you look up tonight and see that steady ochre light in the dark, don't look at it with the frustration of a missed deadline. Look at it with the awe of a student who has finally understood the lesson. Mars is not a new home, it is a warning. It is a world that has been patient for 4 billion years, and it will be patient for 4 billion more. It doesn't care about our billionaires, our flags, or our speeches. It simply is. The story of Mars is the story of humanity's encounter with the actual universe. It is the story of how our greatest dream collided with the crushing weight of reality. And while the rockets may continue to explode and the deadlines may continue to slip, the search for meaning will never end. We may never walk on the red planet as humans of flesh and blood, but in our struggle to get there, we have discovered exactly who we are. We are the children of Earth, trying to understand a sky that doesn't want us, and finding that the only home we will ever truly have is the one we already have. Welcome to the real Mars problem. It was never about the rocket, it was always about the soul.